Okay, so for this lesson, we're going to learn how to use a for loop. Let's do a quick review for a while loop that allows us to count, let's say from 0 to 9, right? So if we were to do that with a while loop, we would do something like this. Maybe int counter, and we'll make it equal to 0. And then what we will do is display maybe what's in count. We could do something like this. So, and as long as we need to set how far do you want count to go, we could say from 0 to 9. So as long as count, so while count is less than 10, right? Then go ahead and display. And let's put these between parentheses here. And here's the curly brace, which is the block for the while loop. Here's the closing curly brace for that. And then we could do printf, the content of count, so printf. And we can print the content, and we could say count equals, and that would be a %d. Let's put a /n there. And now you need to have count here. And let's go ahead now increment count. Otherwise, you'll never get out of this loop, right? So here you need to prime the loop. Here you need to write the condition. And inside the while loop, you need to have a statement that controls the loop, right? So count plus plus is the way to go, which is really equivalent to count equals count plus 1, right? So it's another form or short form to do this. So let's compile this and run. And there you have it. So we're going from 0 to 9. Now, can we do this with an alternate syntax that is a little more compact than trying to remember to initialize the counter, set the permission, and control the loop? But we could do it all in one line. And the answer is yes. I mean, at least for the control area for the loop. Okay, so in that case, we're going to use the for loop. So I'm going to do another one. And for that one, I am going to go ahead and call int I. Okay, so a variable I for iteration. If you want to call it anyway, anything, or you could reuse count if you want. And then you can do a for loop like this. For I equals 0. So notice now I'm initializing I to 0 or setting the priming for the loop. And as long as I is less than 10, so the same condition I'm doing with the while loop, and notice I'm writing all that in the same line. Semicolon, I plus plus, just like you did count plus plus. So all of the controls for the loop are written in this line. So what do you want to do within this for loop? I want to printf I equals, just like count, and that would be a %d /n. This one, you know what? I'm just going to put a space, a comma, and a space for the next one. And then I will do, and that would be I. And then when all of it is done, then printf, give me a new line. Maybe something like this. When that whole line is printed, give me a new line. Now let's see how this works. For that case, maybe I shouldn't say I equal, I should do this. And it will just simply print those numbers in series. Okay? So let's go ahead and run this and see how it works. So compile and run. And there you have it. Okay? So notice that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then press any key to continue because we're done with that value. So what's the advantage of writing a for loop? Well, notice how many lines it took me to write a loop versus to prepare for the loop plus the loop body itself. So it's a lot more lines than a couple lines here where everything is compact. Another advantage is when you know how far you need to iterate, then a for loop is probably your best bet. Okay? All right, so let's do another example with for loops. So let me just write down, this would be my loop 9.c. We're going to do a small accumulation or accumulator loop, right? Where we're going to calculate the average of total values we accumulate, okay? So objective, using a for loop to accumulate a running total, then display the average value collected. So we're going to divide by the number of iterations we're going to need. So author and date is today. And let's go ahead and include stdio.h. Let's write down our int main function. And let's hold the screen here for us. Return 0. Okay, let's save this. And the file name will be called myloop9.c, which I will also provide for you to replicate. And let's save this as a .c program. And just save that right there. There you go. Now, if I compile and run this, it will simply press any key to continue. This is where we are. And I want to keep the screen to appear right here, okay? All right, so let's go ahead and have a value that we need to accumulate. So maybe something like this, float, accum, and set it to 0.0. This is, think of going trick-or-treating to a bunch of houses, and the accum is the bag where you're going to put the candy, okay? Now, when I say a bunch of houses, we're going to use a for loop if you know exactly how many houses you're going to go to. In our case, let's say we're going to go to 5 homes. So int, okay, max count equals 5. Maybe that's as far as I want to go. Okay, and maybe we need to have an actual count that says that will progress, or so that way we can keep track where we are. Maybe something like this, int count. You don't need to initialize it to 0 unless you're doing a while loop. And then for the for loop, it will be something like this, for count. So initialize it here. And notice it's an integer, so 0 is fine. Semicolon. And as long as count, okay, is less than 5, or in our case, max count. So you could put 5 there, or the value max count, right? And then count plus plus. So what do we do here? Now, we're going to do a few things. So I'm going to put curly braces for this for loop because I want a block of code that belongs to this for loop. We're going to ask the user to enter an amount that you will put in the accumulator. So printf, enter an amount. Now, this could be a temperature, it could be a number of candies, it could be anything, right? It could be money. So that's why I left it as a float. So it's a little more flexible than if it was an integer. Integer, you're going to have to enter whole numbers or things that are whole, right? This here allows me to enter things like 55.3 as an input, right? So, and if it is a float, so make sure you do a %f here and percent, okay? Now, I'm not going to straight up put in the accum. I'm going to need a variable here to collect. So let's call it float, and let's call it collect. And then we're going to put it in the collect variable right here. Now here's how we accumulate. We're going to say accum equals the previous value of accum plus collect. Now, there is an alternate syntax for this. Let me write it up right next to it. Accum plus equals collect. This would be the alternate or shorthand syntax for what I just did. Basically, it means take the previous value of accumulator, add whatever you have in collect, and store it in accum. So this plus equal is used a lot in accumulation. It is a shorthand for this accum equals accum plus whatever you want to add, right? So in our case, the collect, okay? And store it in accum. So if you want, and after you get to this code, rewrite it using the shorthand version of this line, okay? So now I'm writing the formal version of writing this line. Okay, so now that we've had all of this, so can we print the running total? So you could do something like this, printf, running total, equals. Now, if it's money, you can put a $sign there, whatever it is. So in our case, I'm just keeping it generic, and I'm going to put a %.1f or 2f in case it's currency, because you need 2 decimal points for pennies, right? Just in case. And that would be the accum. So that way we're verifying what's in the accum. Okay. Now, let's run this for a second and see if we're indeed accumulating, and then we'll print the average once we're outside the loop. We don't need to stay in the loop to calculate the average. Once you've accumulated all the candy in the bag, then you can figure out, okay, I'm done with the homes. I can go ahead and sit down, unload those candies on my kitchen table and start counting, and then divide by the number of homes I've been through. So you have some sort of an algorithm, and then to figure out, on average, this is what I collected without specifying that house I had 3, the other one I had 2. You just want to know, on average, what did you have per household? And that will be the next thing we do. But right now, I want to check the loop and make sure everything works the way it's supposed to. So let's compile and run and enter an amount. So we're in the first iteration of this loop. All right. So let's say I enter 1. So running total is 1. All right. So let's say I enter another 1. Running total is 2. Let's say I enter 3 this time. Then running total is 5. And let's say I enter 5 this time. Then running total, because you added 5 to 5, is 10. Let's say I enter 1 now. So running total is 11. Okay. Maybe something that might be interesting is to display where we are, right? So maybe a line number that shows where we are. Maybe here I might say %D. Make it interesting and put a dot, and then in here put count, just to show where we are in count. Let's try this, okay? And compile and run. Enter an amount. Let's say 1. So we're at 0 the first time around, okay? We could offset this, by the way. I could add a 1 in the printf statement to do this. So let's say enter 3, so running total. Let's say enter 11, and running total. Let's say enter 44, running total. Let's say enter 0, which is fine, right? And it will stop here. So from 0 to 4 is 5 times. Could I have put a +1 here that will have no effect on count? And the answer is absolutely. That's called an offset. And it would have shown 1 instead of 0 to start with. So mere mortals will not be freaked out by your program. So let's go ahead and compile and run this. And let's enter $11. Notice 1 instead of 0, right? So now you're going to get 1, 2, 3, 4, 5, $33. Okay, so that's 44, 22, 0. Let's say $2. Okay, $68 on the 5th house total that you've accumulated. Now, what is my average? So for that, we're going to be outside the loop, and we could do the average right in the printf statement. Okay, and we could do something like this: printf the average take equals %.2f /n, give me a new line, and then write the formula right here. So what are we going to do? Well, you have accumulated something, accum, and then divide by max count. Now, this is not an integer division since accum is a float. Okay? Yes, the denominator is an integer. That's okay. We don't have an integer division, so you're going to get a float. All right, so now let's go ahead and see if this works. Compile and run. And let's say we enter the first time is an amount of 11. Second time is an amount of 11. Again, 11. Do you know the average is going to be what? Anybody? 11, right? So you've collected $11 per house on average. And it was true. I was consistent with that. So now, if you run it and you have variances and so on, not a big deal. Then it will calculate the true average. So let's say I have a 1, a 10. So we know the average by now is 5. Let's say we have a 3 and a 7. And let's say we have a 5. So what's my average? 5.20. So it's as you can see, it converged to 5.20. I had the extreme of 1 and 10, and then, or 11 or whatever, 10, and then went down, right? Converged towards 5. Fantastic. So now you can see a practical use for a for loop. So this can step you through an accumulation, right? Just like the previous example we did, steps you through a count. Okay, so it's all up to you what you want to use your for loop for. Can you go backwards? Absolutely. You could have the count at a high number, and as long as you didn't reach the low value, do a count minus minus. So do that as an exercise. Create a reverse counter or something that will count down, or a down counter, right? So that'll leave that to you to change. So you put your max value here, and as long as you don't reach a min value, whatever you want to reach, make sure you turn this into a count minus minus if you want to go backwards. For counting, okay? It wouldn't matter here if you're going from home to home, forward or backwards, you still have to go through 5 homes. But for the previous example, that would matter because then you would be counting in reverse. Let's do that. Let's say I want to print in reverse, and that's a printf here. So we've done this example. I'm just adding a feature to it, counting in reverse. Okay, so /n. We're going to do the same thing. And let's just show you. So for loop, we already have an I. So set I to some value. So I equals 9. Okay, and we're going to go as long as I is greater or equal to 0. 0, we want to include 0 there. I minus minus. And then we're going to printf. And that would be %d. And let's put a space between the numbers. And let's do I. And then give me a new line outside of the for loop. So printf /n. So let's see how that works. So let's compile and run this program. And there you have it. So notice it starts at 9 and ends at 0. Okay, so you could do counting in reverse with a for loop. Now, if you were to do it in the example for the accumulator, it wouldn't matter if you go in reverse or forward. You still have to go through 5 homes to collect.